In this video, we're going to look at complex numbers in polar form. Now, we've talked about complex numbers. I is the square root of -1. But we want to look at these a little bit differently, and this is going to allow us to do some more things that to this point were very difficult, if not impossible for us. So if we remember looking at this, 3 plus 2i. Well, to do this, I would have to FOIL 3 plus 2i. And I would do first 9 outside, inside, and last. We would know that I squared is the same as -1, so this would become -4. So I would get 5 plus 12i. Now, where this gets difficult is if I want to look at something to the 5th power. I don't really want to have to write this out 5 times and try to FOIL it. That's going to be too hard. Arithmetic would be nasty. So we need another way of talking about complex numbers, and that's going to be polar form. This is going to be very, very similar to what we've already talked about with rectangular to polar form of points, and also back with our vectors in component form. Now, if we think about two numbers, 5 and 2, and I said which number is greater, I think everybody would say, well, 5 is bigger. However, if I said which number is bigger, 2 plus 4i or 5 minus i, it is really hard to determine which complex number is bigger. How do we determine that? Do we look at the real part? Do we look at the imaginary part? How do we figure that out? Well, to do that, we need to introduce something new, and it is the complex plane. And the way the complex plane works is we take any complex number and we use z to represent variables in the complex plane. Kind of use x normally. And when we graph these, our x-axis is our real axis, and our y-axis is the imaginary. So if I have the point 2 plus 3i, on my graph, that would be the point 2 plus 3i over 2 up 3. And if I have -3, 1, 2, 3, minus 2i, that would be this point. Now, what we do then is we determine which number is bigger. So we do it similar to how we did it with real numbers. How far is a number from 0? Kind of like absolute value. So what we're going to do is we're going to determine, to say which of these two numbers is bigger, which number is further from the origin. So once we graph our point on the xy plane, and this is where a lot of the applications in the real world come from, in this xy plane, in graphing complex numbers, in electrical engineering and other engineering areas where this is used in real world applications, even though they're called imaginary. It has to do with graphing these numbers on this complex plane. So what we want to look at is this distance from origin, and it's kind of like absolute value, but we use these two lines here for complex numbers. So I go to the point 2, 3, and I want to find the distance. What is my distance from the complex plane? Now, to find this, I could use my distance formula, but this is just a right triangle, where it's 2 by 3. So my length is just 2 squared plus 3 squared, which is the square root of 13. That is my distance. That is the length of this number. So when I look at these two numbers, and I have 2, 4, 1, 2, 3, 4, and I have 5, -1, What I want to determine is if I want to compare these numbers, I can't really compare them as they're written. What I want to compare is kind of the absolute value of the one compared to the absolute value of the other. So in this one, it would be 2 squared plus 4 squared. 16 plus 4 is the square root of 20. And over here, I would have 5 squared plus 1 squared, which is the square root of 26. So this number is further from the origin, the 5, negative 1, I. So that number is bigger in terms of this absolute value or distance. So how can we use this polar graph for our complex numbers? Well, what we're going to do is look at our polar form. And this is just like what we've done previously. If we have this 2, 4, we can find our r and our theta. Now we're back to right triangles and all that kind of stuff. So we do have some formulas, and these are the same formulas when we did polar form and rectangular form in the previous homework. Same idea. They have these formulas. If all else fails and you can't remember the formulas, we just have a right triangle, and you can just solve the right triangle, and you can get to the same place. So let's convert 5 plus 2i into polar form. Now, if we use our formulas, I keep using z back from our polar. We're going to use our length of z. It's the same thing as r. This is just the square root of 5 squared plus 2 squared, which is the square root of 29. That's that formula. And to find my angle, I just do inverse theta 2 over 5. Now, this is all calculator. I'm going to have my calculator in degree mode, 2 divided by 5, and I get 21.8 degrees. So those are the kind of my rectangular and polar form of a point. But I need to use this and this to get my polar form. So let me jump ahead here. What we're going to do is use this formula, the polar form. Cosine theta plus I sine theta. So I'm going to then write this as the square root of 29 times cosine of 21.8 plus I sine of 21.8. And then if I would distribute this through 29, square root of 29 times the cosine, there's my x, there would be my 5. Square root of 29 times my sine, there would be my 2, and there is my I to give me my polar form. So let's try another one. First I want to find absolute value of z, which is the square root of negative 3 squared is 9, plus 2 squared is 4, square root of 13. I need to find my angle, and that is negative 2 over negative 3. Now I need to be careful, because when I do inverse tangent of negative 2 divided by negative 3, I get 33.69. However, if I think about where is this point, it's over 3 down 2. So I don't get 33.69, that's in my first quadrant, that's up here. I need to add 180 to it to get 213.69. So in polar form, it's the square root of cosine of 213.7 plus I sine of 213.7. Now we're going to keep writing that sine plus cosine plus I sine. So when we write our polar form here, many times we will simplify it down, and I will just write the number and CIS. And we all know that that means cosine of theta plus I sine of theta. It's just a shorthand way of doing it. So here I could just write the square root of 13 CIS to 13.7, and there is my polar form. Okay. Now, if I have the other way, if I have 2 CIS of 100, I got to write a rectangular form. Well, just like before, I would do 2 cosine of 100, 2 sine of 100, because remember this is equal to 2 cosine of 100 plus I sine of 100, and 2 cosine of 100 is negative 0.35. 2 sine of 100 is 1.97. So this would be the point negative 3.5 plus 1.97 I. So there is that in polar form. And many times what's going to happen is if you have a nice rectangular form number, it's going to get ugly in polar form. And if you have a nice polar form, it gets rectangular, it gets ugly in rectangular form. Okay. So there are formulas for polar form and rectangular form. Okay. And the first homework is just going to be converting back and forth between polar and rectangular form.